Hello and welcome. I've been asked to do a video using Kali 2021. I'm using 2021.1, but as long as you're using one of the 2021 variations, this should be fine. We're going to be talking about Metasploit, and it's going to be more for beginners, kind of explaining how to get it working and all of that. First and foremost, because I've had these videos flagged before, this is for educational purposes only. This is for ethical hacking purposes, meaning you have permission to target your victim. You're not doing anything illegal. I'm not pushing you to do anything illegal. Again, education use only, specifically for the purposes of learning the ethical hacking process. I have to state that because I've had my content flagged and removed before, so huge disclaimer there. So topics we're going to be talking about, kind of general outline is assumptions, scope, foundations, Metasploit, and then directly into our lab work. The reason I wanted to give you a breakdown is because we are going to be covering very specific points, and I kind of wanted to give you the flow there. So the assumption is you have some basic understanding of the terminal, both in Linux and in Windows. If I say open up a terminal, check the current directory, you should know how to do that. Change the directory. Basic command inputs. That's one. Two, you have a basic understanding of virtualization, how to move content back and forth, how to connect a USB drive, things like that. I'm using VMware Workstation, so preferably that's where your experience is with. Next, you have some basic understanding of IP addressing and port numbers. When we set up an exploit, or we copy something to a web directory, us navigating to that directory, us navigating to that IP, shouldn't be foreign. Also, in my lab, I have 3 virtual machines set up. A Kali 2021X, meaning could be .1, .2, whatever, doesn't matter. We have a Windows 10 virtual machine, and we have Metasploitable 3 set up. We're going to be exploiting both Windows 10 and Metasploitable 3. There is one caveat to this. In Windows 10, we will be disabling the antivirus once we get it loaded. That's because of complexity, and we're not going to be dealing with encoders and stuff like that. I want to make this video kind of simple as opposed to more complex. So again, the purpose, the scope of this video. Using Kali, we are going to target Windows 10. Select an exploit, craft the exploit, move the exploit to our Windows 10 victim. Set up a handler, run the exploit, verify Meterpreter has successfully connected to our Windows 10 machine. That's one. Second scope is we are going to do the same task but at a little faster pace, targeting Metasploitable 3. We're going to find a vulnerability, we're going to exploit the vulnerability. So the big differences here is Windows 10, we're crafting our own executable, and then we're moving it to our victim and getting the victim to run it. With Metasploitable 3, we are going to scan our victim and we're going to exploit a vulnerability that is already there. So again, first portion is crafting our own exploit. Second one is exploiting one that's already there. Alright, so let's talk about foundational topics. So things like understanding a vulnerability. Basically, that's a weakness that can be exploited by a threat actor. And basically, this allows us to exploit something that is already there. Maybe it's a tool, maybe it's something. But the goal is for the attacker to find a vulnerability, a weakness in a system, and to exploit it. So exploit is something that will take advantage of a vulnerability or a security flaw. So the exploit will actually take advantage of the vulnerability. So let's say we know that you have Windows XP. Windows XP may have a vulnerability. Our goal is to find what system you have, find the vulnerability in your system, and exploit the system so that we can leverage it. So normally, how do we leverage these vulnerabilities? How do we target or attack these vulnerabilities? We do this through payloads. And in simple terms, it's a script that will be used to interact with the victim. Using a payload, they can transfer data to a victim. So the payload is going to be how we actually exploit the vulnerability in the target system. So with that said, we have to have a basic understanding on the target system. Normally, for the target system, we would do some reconnaissance or recon. We want to know the OS version. We want to know the architecture. Is it Windows 10? Is it Windows 7? Is it Windows 10 64-bit? Is it Windows 7 32-bit? That actually helps us. Is it Linux? Is it Red Hat? Is it Ubuntu? Is it is it Ubuntu version 16 or version 20? All of that matters to help narrow down our possible vulnerability list. Also, we also need to understand the services and port numbers that are running on our potential victim or our target. Essentially, what is the target running? Do they have FTP service open? Are they listening on port 20 or 21? Those are all things that can allow us to better find a vulnerability. The end goal here is realizing the vulnerability. And what that means is essentially finding a vulnerability so that we can exploit it. Not all systems are going to be the same. Not all systems will have the same vulnerabilities. So, understanding what the target system is will allow us to better realize that vulnerability. Alright, so what does that mean? How do we realize a vulnerability? Well, we can find them. Vulnerabilities typically have what's called a CVE number, or a Common Vulnerabilities and Exposures number. There's two main databases. This is not the only two. If you look up CVE, you can find tons of them. But if you happen to go, you know what, I'm using Edge, I will go to Google, I will Google CVE, and the first one is going to be our cve.military.org. And then you'll notice as you go through, you can find some other ones. I also want to do the exploit database, so exploit DB. So I'm going to start with my CVE site. Again, these are going to be identify, define, and catalog all of the disclosed vulnerabilities. So if we know we are targeting an FTP server on Microsoft Server 2012, we can see what vulnerabilities are out there. More importantly, if we scan a target, we will get any vulnerabilities that it may know about. So if our server or if our target is vulnerable to CVE 2012-6339, well, we can actually go look at that. We can specifically look up the CVE number from a vulnerability scanner. Our exploit database is also a list of current exploits, and it will tell you what the exploit is, the date, and you'll notice every day we're getting new ones, what type it is, the platform it's targeting, and the author. So let's say we want to target Windows 32-bit. These are the ones that it currently knows about. What happens if we want to do Windows 32 and 64-bit? These are some of the ones that it knows about. And you can drill down the different types. These are remote ones. So this is exploiting Microsoft Internet Explorer. This is remoting SMB in Windows 8. Again, the important part here is to understand if we know what the target system has on it, if it's Windows, if it's Linux, if it is, pick a platform, because they're all going to be here. If it's Ubuntu, okay, so apparently they're not going to let me do the different variations of Linux. Okay, some of them OpenBSD, FreeBSD. So yeah, you drill down to the specific one that you have. I don't remember what Ubuntu is built off of, so I was assuming they would let me just search for Ubuntu, but it doesn't. That's fine. Anyways, so the important part here is understanding how we can find those vulnerabilities. So the next part would be some basics about Metasploit, since the goal here is to look at Metasploit itself. First of all, Metasploit is built on modules. Each module gives us certain functionality. For example, there's encoders. Encoders are essentially going to be ways for us to bypass antiviruses. So a very popular encoder is this x86 / I can't pronounce that at all. But that's going to be one of the most commonly used encoders for polymorphic XOR additive encoding. Essentially, this helps us modify our code so it's not detected by antivirus. We're not going to be worried about encoding in this video, but I did want to point out that there are encoders. There's also what's called auxiliary models. These auxiliary modules are essentially any additional module that's not used for an exploit. Exploit modules always have a payload. Auxiliary modules don't have to. Auxiliary modules could be anything. You can create your own vulnerability scanner or your own port scanner or anything inside the framework. Anything that is not an exploit is classified as an auxiliary module. So we're going to be using Metasploit. So what do we do? Like, what are the steps? And we're going to break down the steps and then we're going to go through them. Step 1, select and find an exploit. Then we have to craft our exploit. Then we have to exploit our victim. And then we need to set up a handler. Then we need to run our exploit. So we're going to do each one of these 5 steps. So before we jump into our Kali, I want to make sure we understand. We need to be able to search and find our exploit based off of some type of information. Our exploits are going to have rankings, and rankings are really important, and I wanted to point this out before we start searching for our exploits. If an exploit ranking is excellent, basically this means the exploit typically never crashes. If the exploit ranking is great, then the exploit has no default target and either auto-detects the appropriate target or maybe doesn't. And again, the exploit's stable. Good, the exploit will have a default target and is using the common sense, and again, normally doesn't crash. Normal is reliable, but may not be able to do certain things. Average and low, you want to stay away from them because they may be unreliable or very difficult to exploit, or the exploit itself is unstable. Why does this matter? When we go to target a system, if our exploit crashes, that might cause our victim to realize what we're doing. Or maybe if the exploit crashes, it gives what we're doing away to an administrator that's monitoring those machines. So we're not quite sure. So how do we work with searching and finding exploits? First of all, we have to find details about our target system. I already said this earlier about reconnaissance. Maybe we're using Nmap to determine our services, OS types, or our architecture. I misspelled architecture for some reason. We're going to be looking at specific details. Maybe we're looking at IPs, port numbers, things like that. So let's jump into our Kali and let's do some basic reconnaissance and basic searching. Alright, so I have a Kali machine. I'm logging in. First thing I'm going to do is open up my terminal. I want to know what my IP address is. So if config. My IP address happens to be in the 192.168.50. range. My subnet lets me know that it's locking in the first 3 octets. So I'm going to use Nmap. And I'm going to be looking at this network. And I'm going to use the TAC O. If you get a requires root privileges, do a sudo and scan again. Nmap will scan to determine the operating system with some relative ease, hopefully. And this can take a few minutes or it can take longer. Alright, so what did it find? Well, first of all, scanning 1, it found this information. Well, I know 1 happens to be my host machine. 2 happens to be my default gateway. The 192.168.10.134, it looks to be a Windows machine. It's running Microsoft services, it's running SSH. And so it could be Windows. However, you notice it determined that it's running a version of Linux. Linux 3 or 4, the OS could be CPE. It has some type of Linux kernel, so maybe it probably isn't Windows. Even though it had Microsoft port 445, doesn't necessarily mean it's Windows. So we know that 134 is our Linux machine. Here we have 254. Again, we're not showing any services. And then lastly, we have 135. 135, I'm going to scroll all the way up, happens to be my Kali machine. So 135 is not my Windows machine either. This is Kali. Alright, so turns out my Windows 10 machine fell asleep, so I'm going to go ahead and scan again. Yeah, this fun part is Windows 10 likes to fall asleep, especially as a VM. So we'll just redo our scan. Hopefully this doesn't take very long. Alright, there it goes. We found a new machine, 136. It found 135, we already know is Linux. 134, we already know is Linux. 136, it's pretty sure it's a Windows. either a XP or greater. The aggressive OS guess would be XP Service Pack 2. So this is not always accurate. It is Windows 10, so I was going to assume it would at least be similar to it finding Windows 10, but you know, that is okay. We know it's a Microsoft platform, so what we're doing today will be okay. You'll notice that this one only has port 5357 open. These ones have other ports that are open. So this provides us some basic information. We know some of the services, we know a general OS, we know a general architecture, and we know some basic address and port numbers. So that gives us some basic information. So I'm going to go back one slide. How do we search for exploits? How do we find those payloads? So back in Kali, I'm going to do a Control-Shift-T, open up a new tab. I'm going to go ahead and open up my MSF console. Since we're going to be using Metasploit, might as well get it launched now. And I'm going to be searching. Well, first, I don't know what's here. It says there's 2,106 exploits, 111 auxiliaries. So I'm going to do help. So it doesn't like just random commands like that, but typically when you do that, if you do tac in front of it, you may actually get something more, but we already know that's not the case. So yeah, with help, it's not tac help, not yet, just the traditional, you know what, I will clear my screen. You can use the tac help when you have an additional command in front of it. But if you want just basic help, it's just help. And then you go to the very top and you get the core commands. You can see like the banner, you can see the features, the history. You can see certain information. If we're looking in the modules, we can see the advanced options, but I'm more interested in search. And if you're looking at the database backend, you can go through some of the database commands, there's developer commands, and so forth. So, search. Well, we got to give it some options. We can't just do search. We can search by CVE number. We can do exploits. We can do platforms. We can do by rank or by target. So let's do search FTP. So we can do certain types of searching where we search for keywords. So these are all the possible ones for FTP. Clear search Windows. Oh. If we're looking for Windows, we could do that as well. So when we're looking for an exploit, the goal here is to do some reconnaissance, find our system, what is our system, and find an exploit that would work, that would be targeting them. So I already know that we're going to be, in our first task, crafting a executable. So we're going to be doing a reverse TCP shell. The nice thing here is you can do like PowerShell, you can do other forms of exploits, but for what I'm doing, for our first scope, is going to be more targeted. So we've already done our reconnaissance. So what we're going to be doing is using MSF Venom, and we're going to be creating a executable that we can transfer over. So the general breakdown is going to be something like this. MSF Venom, we give it our payload, we give it our L host, our L port, and we bump it out to an exe. Well, you may also want to give it a path. Well, the nice thing is, you don't have to do an exe. You could do a Python script, you can do a bash script, a Linux script, a Mac script, and you can do like 1,000 other different types of exploits. So it doesn't have to be an exe. It's just, I happen to be choosing the exe, so that's what I'm going to be doing. So again, our breakdown will be MSF Venom. We have to give it a payload, so tac p space the payload. We have to give it our L host and our L port. That is the port and IP address of Kali. We want a listening IP, Kali. We want a listening port on Kali so that when our target is infected, it will call out to our listening machine. We're doing a tac f because we're doing a file. We're setting our file to an exe, and either we're going to carry it into a reverse.exe or we're going to give it a path. So it really just depends on how we want to do that. So a common question I get is, what payload? What am I trying to do? How am I trying to exploit my system? So when I'm sitting at an MF console, I'm going to do a show tac h, and we can do show. If we just do show, it'll show everything. We could do encoders, we could do exploits, payloads, our auxiliaries, and other options. I want to go ahead, I want to do a show payloads. And I scroll up. Notice we have a rank. We already talked about rank. Normal is acceptable. If it's a low one, we probably want to stay away from. And notice we have AIX, we have Android, Apple, BSD, Unix, Windows. So we're doing a command window. We're not doing a PowerShell reverse TCP. There's still a ton of payloads that are available. Python, PHP, Ruby, Solaris. We have some DLL injects. Those are for later videos. We have several different versions of our reversing options. So the question becomes, well, which one are we selecting? How do we know which one to select? We're going to be doing a variation of our Windows, but we want a Meterpreter shell. So we're going to be doing a Windows Meterpreter reverse TCP. So VSP. We're going to be doing this guy right here. Number 386. But what does that mean? So if you're looking at the payload list, you'll notice that some payloads actually have the exact same name, but in a different format. For example, Windows /shell /reverse TCP, and that we can also see a Windows /shell _reverse _TCP. One of the following forward slashes will indicate the staged payload, and the one with the underscore means it's a single. So what does that mean? Again, when we have a forward slash, it will be denoted as a staged payload. If it's an underscore, it is a single payload. So here, this is going to be a staged, but this one is going to be the single payload. So what does that mean? A staged payload means that your payload consists of two main components, a small stub loader and the final stage payload. So when you deliver the Windows shell reverse TCP to the target machine, for example, you're actually sending the loader first, and then the loader gets executed, and then we'll ask the handler to actually send over the final stage, the larger payload. And that's how you end up getting the shell. If we have a single payload, this will mean the single payload means that it is meant to be a fire and forget type of payload. This can be used when targeting a no network access device. So generally, the Meterpreter is the most popular payload. So if we're dealing with a Metasploit, almost everything is going to be a Windows Meterpreter reverse TCP session. That's going to be one of the more common ones. However, if you're using Linux, then it'd be the Linux /Meterpreter /reverse TCP. Again, if you're trying to do that and it's unable, you could also try a cross-platform one, like a Java Meterpreter or a Python Meterpreter reverse TCP shell. So again, the important part at this stage is to understand stage versus single. If we're dealing with a system that has no internet access or not stable network access, the single option is going to be better than the staged option. Alright, so let's do it. Let's go ahead, let's set up our MS Venom. We are doing our payload. Make sure I spelled Venom correct. We are doing a Windows MSF Venom, yeah. We are doing a Windows, we are doing a Meterpreter. Alright, sorry about that. So MSF Venom, TAC P. We are doing one thing that I end up doing quite often is I will fat finger this part. So Windows Meterpreter. That's one of the reasons I said earlier the number, so I can quickly reference it again. So there we go. And with Venom, we are doing P. We are doing our Windows Meterpreter MS Venom. So after that, we actually have to do some of our options. We need to set an L host. That means L host. That's going to be the IP address of our Kali machine. And again, let's go back to our first tab. There's config. You want to make sure that you do the correct address because this exploit will call back to this address. So it is lhost is equal to. We have to do an L port. This is going to be the listening port. So it can be any random port, but this is going to create a binding or a socket. This IP address and this port number together is what's going to allow Kali to listen when this exploit is ran. So from there, we'll do attack F, and we are doing the file type exe. And so I'm going to do my first one, which was caret, and this is where it becomes kind of important. You want to name this something that you can get the user to click on. So here we're doing update.exe. It will create it. We didn't select a platform, so it's going to use Windows. We didn't select an architect, so it's going to use x86. And it generated our payload. Well, or it generated our actual exploit with the defined payload that we selected. Where is it? pwd. We're in our home Kali folder. So it's in our home Kali folder. Or if you guys want to use attack O, you can give it a better path. You can give it the specific path that you want to put it in. So home, Kali, desktop. So I'm going to move that over. Alright, that is a little weird. It should have copied it to our Kali desktop. Alright, it did not like that whatsoever. That is because we actually have to give it the rest of the details. So it's not so much just our desktop, but we have to give it the name of the file. Give it a second, it will generate, and there we go. So I mean, I did that on purpose. I wanted to show you that you have control of where you want to put it. I'm going to go ahead and dump the one that was on the home folder. That way I just have the one that's on my desktop. So we've completed this part. So now we have to talk about exploiting our victim, the delivery. How do we get it to our victim? So we can do it as simple as putting a USB in. And problem with that is if we have a USB and we copy it back and forth, that can be cumbersome. It's definitely doable, but is that the best option? We could do some form of web. Maybe we do it on a web server and we get the link to the victim somehow. Or we can do social engineering. And again, same general thing is the goal here is to pass the exploit from us, the attacker, to our victim. Today we're going to do the web path, the web route. So I'm going to show you how to verify Apache is running and how to copy the files in the correct locations. Alright, so what I'm going to do is I'm going to open up a new tab. I want to check my services. So it'll be service space tac status tac all. And that's going to run through all of the currently running services. If you see a plus next to Apache 2, that means it's running. If you do not see a plus next to Apache, it's not running. So how do we get it running if it's not? You would do service, but instead of tac status, what service are we trying to run? Well, we're doing Apache 2, and if it's stop, you would do start. If you want to restart it, you know what, I'm going to stop mine. So I will do my status. Apache isn't running, which means my website's not running. So I will go ahead and type start. Because that requires administrator or a root user, you'll get prompted. But now, by doing that, by starting it, it's now running. We see the plus sign. So who cares about like that? What's the point here? Our Apache 2 will give us a web portal for us to be able to access our exploit from our victim. That way we don't have to worry about doing it on a flash drive and maybe having the AV find it on the flash drive and yada yada yada. That makes it a little more cumbersome. So let's let's check that this actually even worked. So we will go Firefox, 127.0.0.1, and we get a default Apache page. But the problem with that is we need to be able to put this data file somewhere that's accessible. So I'm going to go home. So this is normally done in var www HTML, and you'll notice this is the page that is loaded. Well, I want to make a new directory here. You'll notice that we don't have so what I'm going to do is I still want to keep my Meterpreter tab open. cd var mkdir. I will do a directory called share. If you get a permission denied, just sudo it. And again, we will go back, Firefox. And I'm using 127.0.0.1 because that's my loopback address. I can also do the 192.168.135. Now, if we do /share, we get our share directory. That is important because if we do copy home /Kali /desktop /update.exe space where we're copying it to, which will be var www /html /share, we can do that. Again, it is a protected directory, so I'll do a sudo. And there we go. If we hit refresh, our update.exe is now there. Now, the first time you do this, it seems kind of cumbersome, but if we're looking at a delivery mechanism, being able to do it through a web link is a little bit easier than trying to do it via a USB drive. Alright, so what that means is we need to jump into our target Windows 10 machine that happens to be powered off again, and we're going to run this update on that machine. Alright, so remember, we're going to that web URL on our victim. So 192.168.50.135, and again, the main page is our Apache, and we have our share. So when you first download it, you may see that it may cause some harm. Let's try that one more time. So update may cause some harm. I'm going to click on the 3 dots. I want to keep it. I want to keep it anyway. So I'm going to go to my downloads folder, and there it is. However, the second you try to do anything with it, your AV may actually show that it's there. So turn off your AV. So I'm going to turn it on actually. And the second the AV actually turns on, it should show that it's virus. So make sure your AV is turned off. You should be as simple as click on it and click disable. I forgot that I permanently disabled it so that it won't keep popping up. Alright, so you can't just run it yet, because if you run it, it doesn't do anything. It just sits there. That is because, while it may have called back out to our Kali Linux, we haven't finished what we need to have set up in order for this to work. And again, our victim has ran our exploit and nothing happens. That's where step 4 comes into play. We have to set up a handler. The handler is going to be what receives our requests. So again, let's jump into Kali. In our MSF console, we need to do an exploit, so we will use the use exploit I don't know why I did attack, so use exploit. We're doing Windows, we're doing a that's not this is the exploit, not the payload, so we are doing a multi-handler. Our generic is our reverse TC shell. However, we're going to be setting our payload, so set payload. Oh, nope, I hit tab too many times, so if you keep tabbing it, it will actually ask you. So we want the Windows payload, Meterpreter, and again it will show all of them, so Meterpreter. That's the positive and the negative with our tabbing, so reverse TCP. So I will do a show option. So here we have our L host and our L port. This has to match up with what we did with our exploit. So first of all, set L host 192.168.50.135. Set L port to 1234. So that helps create the socket binding. That takes that IP address and that port and they combine the two. Now, to make sure this works, we will do an exploit, tag J. I don't know why I did tag J. I'll just do a exploit. And it has decided that our binding isn't going to be functioning. So this right here, exploit failed, bad config. Show options. .192.168.50.135. Let's double check if config, it is 50.135. When we did our crafting, here it is, we crafted the L port and our IP address the same. Alright, so normally when you would do the exploit, it would just function. If it doesn't, we can type help, and we are looking at our sessions or our jobs. So I'm going to click jobs. It failed because I actually already had it running. So I'm going to go ahead, I'm going to stop. So jobs tac K0. Show options. Exploit. Alright, there it goes. I keep saying socket binding, and this is a perfect example. If you run this once, it binds the IP in that port number. Well, you can't bind it again. We already had a job running, that is why it was already binded. So we couldn't do it again because the job is already there. So you'll notice now it's listening. It's waiting. So we ran the exploit on the Kali machine. That started our handler. That started our listening process. Now we have to run it on our victim. So go to our Windows 10 machine. I will run it again. I'll hop over to my Kali. The second I clicked on it and opened it, it actually sent back the first stage, and then it sent the final stage, so we know that this is a staged payload because it's had to send the final stage over. That opened up a Meterpreter session. So what's Meterpreter? Meterpreter is basically it's part of Metasploit. It's the attack payload that provides the interactive shell for us to work with. So let's do it. Help. So these are all of the commands that we can run. So I'm going to do a pwd. So on my victim, it's currently sitting at the downloads folder. To really verify this, to make sure, I will create a text document. I'll call it flag. Flag 1, 2, 3, and some text. So I can do a dir, and I can see my flag. I can see the time and date it was created. I can actually I can cat my flag, and I can see that it's there. I can maybe do a hash dump. I can maybe get system details. So part of this is you would have to go through and you would have to explore what you wanted to do via our Meterpreter. What are you trying to accomplish? I did a read for a material. I found something. I read it with cat. I was able to, well, we could also do uploads, which we aren't going to do. But you know what? I'll try one more. I will do a make directory. So mkdir flag 2. So Meterpreter actually will act as a session connection between us and our victim. We can pretty much do what we want. What is interesting is, let's go ahead. I have a Logitech Brio. I have a web camera. File clear. Apparently not. Alright, so maybe I want to get a list of my webcams that are on my target. So webcam list. So maybe I want to take a snapshot of my camera, and that's me. I didn't comb my hair, but you are actually able to capture content using the victim's webcam. And again, the goal here would be to go through all this entire list so you understand what you're trying to accomplish with Meterpreter. But that has completed the Windows scope. That has checked it off. We've crafted an exploit, verified it. We even did a screenshot to verify. So, with that said, let's move into our Metasploit 3 scope. So at the beginning of this video, I did say we were going to do a Metasploitable 3. So we're going to look for vulnerabilities. We're going to use the built-in tool Legion, and we're going to exploit one of the vulnerabilities inside Metasploit. We're going to be specifically exploiting ProFTPD in Metasploitable. So let's jump into Kali, and let's see what we can do. So we still have everything open from our Windows machine. So let's go ahead, let's exit out of here. Jobs, there's no active jobs, so exit again. So I'm gonna go ahead and close out of everything. Alright, I will ignore the update. I will delete it. So first things first, you know what? I'm not going to use Nmap. I just said I was using Legion, so I will do Legion. Legion is a graphical tool, so we will add our network. Well, we could also do a Nmap scan to see our victim. Our victim happens to be 192.168.50.134. So we can leave it as easy and we will submit. This is going to take some time as it runs through it. What it's doing is it's pre-scripting some Nmap scans. And it's going through different stages, it's capturing different things, and normally this can take several minutes, 20-30 minutes. So with this, you pretty much let it run and you back away. While it's running, it may look like it freezes. Again, be patient with it. I've had this take some serious time, so just let it go through and process. It may stop running. Mine stopped running, so I just restarted it and set it over again. But I actually already found what I want to be attacking. I want to be attacking my ProFTPD. Even though my scan is not finished, it's still going. I'm going to let it finish to see what other ports it finds. That way we could possibly discuss other ways to attack this. But for now, I'll let this scan finish, and then we will show you how to exploit this ProFTPD service. Alright, so this is going to keep going, and at this point it's been running over 35 minutes. So the big ones is, again, I'm going to be looking at this ProFTPD, but if we wanted, we can actually try to exploit something like the HTTP or IRC or the NetBIOS. We can try to target other services that are running. But again, the scope was specific to exploit the FTP, so that is what I'm going to do. I'm going to go ahead and open up a new tab. Control-Shift-T will do that. I'm going to go ahead and open up my Metasploit console. So the difference here is we're not crafting anything. The thing here is we will be taking a already pre-built exploit, and we're going to be looking at a known vulnerability. So we will be using the exploit. It's in Unix. It is an FTP. It is for Pro FTP, and we're going to be looking at mod copy. Show options. So the big one that we need to set is we need to set the R host. So set R host, and we need to set that to our target. And the nice thing there is we should be able to run it and see what happens. Oh, we didn't set a payload. So we will do set payload. We're going to be using the CMD, Unix, reverse. We'll be doing a reverse Perl. Let's see if that works. Oh, I was too fast with that. So I set my payload. We need to go ahead and set some options with it. So show options. So for our payload, L is listening, so we need to set L host 192.168.50.135. Set L port. You know what? I'll do 444 this time. Show options. So here we have our target. Here we have our Kali. So we're getting an exploit no because we can't actually write to that directory. Alright, so looking over these options, we don't have a proxy. We set up our R host, we set up our L port and our FTP port. But you know what? The site path, we already looked at our Apache and we already know set site path. That needs to be set to var.html. So SSL should be false. Target UI should be, that's good. So let's try running this again. Ah, there it goes, and it opened up a shell. So I get asked, why did I look at the site path? Well, the site paths in Linux are typically var www/html. That's where everything is kind of grouped together. We did the Apache one earlier to point that out. Normally things are not left in the root www. There's always the subdirectory html. And that's what we did. And you'll notice we have a session to it now. We didn't set a Meterpreter session, we just set a session. So you should be able to do this, but instead of doing the Java payload, do a different payload. See what happens, see what you're able to connect with. Maybe you're able to get a Meterpreter session to this machine. Part of this is exploring what you're able to do. So we've met using the vulnerability scans using Legion. We exploited Pro FTPD. So that is it. That was the goal of this video. We exploited our Windows 10 machine. We met the scope there. We met the scope for Metasploit 3, specifically targeting FTP. So hopefully this answered the questions that I received. If you guys have any other questions or comments, let me know, and I'll try to answer them as soon as I can. Thank you, and I hope you have a good day.